A cylindrical metal can, open at the top. So there's my well-drawn cylindrical metal can, open at the top, is to have a capacity. Capacity, I think we've seen that before. Addy, capacity is a fancy word for volume. So volume equals 24 pi. The cost of the material used for the bottom of the can is 15 cents per square inch. The cost for the side of the can is 5 cents per square inch. What is the minimum cost possible to produce such a can? Okay, cost is what we want to minimize, so let's write that equation first. If I need my roadmap, find an equation, set the derivative equal to 0, check the sign chart, or if you're convinced you're good, then maybe it's okay because it's multiple choice, whatever, just be careful. And then make sure you answer the right question, because this could be asking for radius, for height, for cost. Could ask a lot of different things. Okay, the cost is made up of two different pieces. There's the bottom cost. I think that'd be that piece, and then plus the side cost. Let's see here. I don't think I want to highlight the whole sides, but you know what I mean. And that's 5 cents per square inch. So I'm trying to build up to my equation and not do the thing where you just write down the final equation. So the bottom is 15 cents per square inch. So 0.15 times the area of the bottom of the can. I guess we should put some dimensions on here. So I need the area of the bottom of the can. Well, what's the area of a circle? Pi r squared. So pi r squared times 0.15 would be how much the bottom of the can cost. The side of the can, we did one of these earlier, or last time, where if we rolled out the side of that can, like the soup label kind of thing. So here's those pink stripes that were on the label. And there's the height of the can. And the most important thing on this was, Jake, what's this dimension?
It's like the radius of the circumference.
It's the circumference. It is the circumference. It is the circumference. So I need a formula for circumference. We'll let Jake get away with that as long as Hanya can help us with the formula for the circumference. Okay, be careful. R squared is if there's an area, right? Because you'd have two dimensions. So it definitely won't have an R squared. It'll have one dimension of R in there. Somebody help her out. Oh, 2 pi r for the circumference. So the area of that soup can label, the lateral surface area, would be the fancy word for it. Well, the cost was 0.05. That area would be 2 pi r h. So there's my equation that I would like to take a derivative of. But Chase, why would I not like to take a derivative of it right now? Not the pi. I mean, the pi is kind of annoying, but I can't really fix that. Too many variables. So I'd like to get rid of one of those variables. It would be nice if there was some other information, Jameson, that I could use to figure out a relationship between R and H. What else do we know? It does give me the volume. So what can I do with the volume? Perfect. The volume of the can is pi r squared h. So I've got a volume equation and a cost equation. Maybe this seems obvious, but I need to ask it. Nick, which equation am I going to take the derivative of, the cost or the volume? Why the cost? What makes it the primary one? Perfect. We're looking to maximize or minimize cost, so that makes it our primary equation, so we'll take the derivative of that guy. We didn't like it because there were two variables, that's why we've got our secondary equation, our helper equation. You're pretty much allowed to solve for whichever variable you like, Max, but I think there's an easier choice. Would you like to solve for r or for h?
For H.
Why'd you pick h? Yeah, perfect. I'd solve for h, so we don't have to square root it. Pi's will go away, and so h is 24 over r squared. That actually works pretty well in the other equation too, because there's only one h I have to plug it in for. So cost is 0.15 pi r squared plus 0.05 2 pi r times 24 over r squared. Peeking ahead. I need to take a derivative, but I'm peeking ahead at my answers, and my answers are all fractions, so it might be wise at some point to change these to fractions. Maybe not yet. Maybe we could take a derivative first and then change it. Am I ready for a derivative yet? I don't think so. I want to clean this up. So 0.15 pi r squared plus 2 pi times 24. Maybe I do want to go to a fraction. I don't know. Do you know what 0.05 is as a fraction? 1 over 20. If you weren't sure, you could put it as 5 over 100, and then you get to 1 over 20. Okay, now I can take a derivative. I guess I could fraction that one, but I'm peeking ahead, and I know the derivative is going to make 0.15 better, so let's take a derivative first. KK, how about the derivative of 0.15 pi r squared? Don't worry about the 0.15 so much, right? How do I take a derivative of r squared? Yeah. So 2r times the stuff that's already there. So perfect. Fife, you got the harder one here. Remember, that's the same thing as 48 pi over 20 times r to the negative 1. That might be a better way to think of that. So I'm not worried about the 48 pi over 20. That's just going to go along for the ride. What do I do with r to the negative 1?
Move it to the front, and so then the r would become r to the negative 2.
Yes. So negative, I don't know why I don't reduce this, but whatever, 20 over r squared. Okay, and what am I doing with that? You tell me, Reed. What do I took a derivative, why? Like, what's next?
Set it equal to 0.
Set it equal to 0. Okay, here comes our algebra fun. In fact, we're done with calculus. That would be 3/10 pi r minus, let's go ahead and reduce by 4, 12 pi over 5r squared. I'll move the 12 pi over 5r squared over. at some point realize I can mark out the pi's, and those can go away. And you tell me, what do you want to do next? I see a couple of options. Thoughts? Algebra All-Stars? You could cross multiply. That might be the easiest way to go. So 120 equals 15 r cubed. It would be fabulous if 15 goes into 120. Does it? It'd be really fabulous if it went into 120 as a perfect cube. Wow, rigged problem for our benefit. So r equals 2. Again, now the long discussion about, are you sure that's a minimum? Well, there's only one choice over here. There's nothing that says about there's not a minimum. So I'm probably just going to roll with that. If I wasn't sure or I needed to convince myself, I could do r equals 2, and I would get negative, positive. So I know there's a minimum at r equals 2. I didn't really do this, I just know it would work. Okay, so I did the equation, took a derivative equal to 0, sort of did the sign chart, but sort of trusted it was a minimum. Now the right question is, what is the minimum cost? So I've got r equals 2. It's not really my answer. I mean, it's sort of my answer, but what do I do to find the minimum cost? What do I do with, how can I find the minimum cost? Plug it in. Plug it in where, though? I've got 1, 2, 3, 4, 5, 6, 7. So the main question is, do I want to plug it into the cost? Well, kind of giving away the answer. The derivative or the c? C or c prime? C. What am I going to get if I plug it into c prime? A 0. So a lot of people do that, and they're like, wait a minute, that can't be right. The cost is probably not 0. And it's because you plugged it into the slope equation, which you already knew was going to make it 0. So, yeah, let's plug it into the cost equation. And I got to end up with a fraction. So, 15 over 100 times times 4, because r is 2, plus 48 over 20 was 12 over 5 times 2. That would be a safe stop, except don't have that option. Let's see, how do I want to do this? 60 over 100 or 15 over 25? Either way. 60 over 100 is 3/5. How much math can you do at your head at once? Oh, and the other one is 6/5. So I sure hope there's a 9 pi over 5 answer over there. And there is. Amazing. That one. Right? Like, there was one calculus step in there. Finding a derivative. Everything else was algebra and geometry. Okay.